Hello, my name is Ciro Seisler. In this video, I present HardCloud, a novel and simple mechanism to offload computation to FPGAs. HardCloud extends OpenMP directives in such a way that the FPGA becomes just another OpenMP acceleration device that can be used directly from any user program. In this example, we show a simple C code with two arrays x and y and copy the value of each element from x to y. In the top of the code, we add two lines with OpenMP directives to offload the computation to the Intel HARP2 platform. Since OpenMP 4.0, OpenMP supports offloading to other devices. To do that, first, add a device clause with HARP as an argument. Second, HardCloud implements an extension of OpenMP to offload a pre-synthesized module to the FPGA. The new clauses are use and module. In your code, just type after a parallel or parallel for directive use with HRW argument and module with the bit string name, in this case loopback. The map clause with argument 2:x will copy the information from array x to a shared memory. The FPGA will retrieve this information of x. The other map clause has a different argument from calling y. After the FPGA processes the information, it will write the result to a memory region that corresponds to the variable y. How to connect your car? The hardware designer has only to add 5 ports to his IP. 2 of them are simple system signals, clock and reset. The start port receives information from the software to initiate the computation. The finish port is used to inform the application that the accelerator has already processed all data. The buffer port is a system Verilog interface with built-in functions that abstract the communication with the CCIP interface. Here is a simple example of a stub for a system Verilog IP. To request data from the shared memory without HardCloud, it is necessary around 100 lines of code. As you can see in the SV code in the right side, the HardCloud simplifies this request with 3 functions: idle, to set no operation state; read FIFO is full, verify the full status of read request FIFO; and read string, request 512 cache lines from buffer ID equals to 0. The HardCloud interface provides an effortless method to connect the IP core by extending information with the OpenMP runtime and reading or writing the shared memory in a seamless way. Moreover, two operation modes are available to execute a read or write operation, and they are screen and index. First, we are going to explain the screen mode. In your screen, you can see the user module, IP, one HardCloud subblock, HardCloud request with two FIFOs, read request FIFO and write FIFO, and the shared memory. Take into consideration that two variables are mapped to the memory, X with size of 3 cache lines and Y with size of 2 cache lines. The IP call the read request function from the buffer port to request 3 cache lines from buffer X. The HardCloud requester waits until the next subblock status is not busy. When it is ready, the HardCloud requester dequeues the FIFO and sends the request to the subsequent subblock. After several clock cycles, the data A from offset 0 is delivered to the IP. Since the screen mode operation was selected, the next data will be from offset 1, data B. Finally, data C from offset 2. Now, the IP calls the write screen function from the buffer port to write D to buffer Y. Next, the same function is called to write the data E to the next address because it's a string operation. The HardCloud requester waits until the next subblock status is not busy, then write D to offset 0, and after that write E to offset 1. Now let's explain the index mode with another example. The variable size in the shared memory were updated. X and Y now have the same size of 4 cache lines. First, we are going to request 3 cache lines from buffer X with offset 3, 2, and 0. The offset 3 request is done using the function read index with arguments X and 3. The same function is called for offset 2, and finally 0. Then wait until the next subblock status is not busy. Each request is going to be sent in a sequential way. First with offset 3, second with offset 2, and the last with offset 0. The data is delivered in the same order requested. After several clock cycles, the data D from offset 3 is delivered to the IP. After that, the data C as expected, and last data A. Now, the IP calls the write index function from the buffer port to write data H to buffer Y and offset 3. Next, the same function is called to write the data F to the offset 1. Again, we have to wait until the next subblock status is not busy. Then write H to offset 3. After that, write F to offset 1. Thank you for watching this video. For more information, access hardcloud.org.